Solving system of equations graphically. This is actually my favorite method, unless I have to draw the x-axis, y-axis, and then plot the points and everything. If I have access to Desmos, then this is my most favorite method to solve the system of equations. But for you, you're not allowed to use Desmos. I would recommend you that you plot the graph of these two lines without using a graphing calculator, but a teacher is allowed to do so. So I'm gonna go to Desmos straight away and I'm gonna plot these two equations. So we have 4x minus 4y equals 4, and the second equation is y equals 2x minus 5. Now the solution of this system is going to be that point which is actually the part of both the lines, right? The point which lies on the first line as well as the point that lies on the second line. So that's going to be the point of intersection. Point of intersection. That's going to be the solution. As simple as that. You don't have to do anything else. So over here we see that over here the point of intersection is this point, which is 4, 3. So this is the solution because this point lies on both the lines. Now there are, on the basis of, you remember I told you that a system of equations can have either one solution or infinitely many solutions or no solutions. So this is the case of one solution. This is the case of one single solution. So such a system of equations which has one solution is called consistent. This is a consistent system of equations, consistent and independent. When you have one solution. Next, we can have a system of equations with no solution. That is going to happen when you have parallel lines. So for example, if I take a line with same slope, so 2x minus 9, or let me do plus 9. So here we all know that two parallel lines never intersect, right? So these two lines will never intersect. So that's why they will not have any point of intersection. So that's why they are gonna have no solution. So such a system of equations which has no solution is called inconsistent. Then finally we have a system of equations which has infinitely many solutions. First of all, you just need to be very careful that the slope of two parallel lines will be always same and the y-intercept will be different. Now so now I'm going to write two equations which will have infinitely many solutions. So for example, let's take the same equation, y equals 2x minus 5, and now just multiply this equation by any number. Let's multiply this equation by 3. So you get 3y equals 3 times 2x is 6x minus 3 times 5 is 15. So the moment I press 15, you will see one more line, but it will be exactly on top of this green line. Okay, the moment I press 15. See, now the purple line is exactly sitting on top of the green line. both the lines are coinciding. Okay, so these two lines have infinitely many solutions. Infinitely many solutions because they are exactly, there are infinitely many points which are common. Now, how you will identify such system of equations? You will see that, the coefficients will be multiples. So here the coefficient is 1, here it's 3, 2 and 6, -5 and -15. So basically my second equation is 3 times the first equation. Now such a system is called again consistent and dependent.